Let's keep this interactive, so don't let me roll past anything that you find interesting or that you want to be argumentative about. And also let me say that this talk is maybe a bit unusual in that I'm not primarily here to tell you stuff, but I'm primarily here to find out stuff, either from you or from people that you know. So I'm normally at the University of Colorado. I'm visiting this area for about 6 months, and one of my missions here is to understand the topic of this talk, taking advantage of the fact that this is a world center of research in this kind of thing. So perhaps some of you work on this kind of thing, or maybe even if you don't, you have ideas about it I'd love to hear about. And then some of you will have a sister-in-law who is somebody who works in this area, and I'd love to be in touch with them. I'll say more about some of these possible connections later on. So just adding to that background, so the particular role I'm playing here is connected with something called the Coleman Institute for Cognitive Disabilities. It's been running for close to 20 years in Colorado. The mission is described there to really explore how technology can, as you just heard, really enhance what people are able to do. And one of the ways the Institute works on this is to inform its stakeholders, who are many and diverse, about developments that might be consequential for them. So you'll see that the stakeholders include people with disabilities themselves, and then a bunch of other kinds of people, including government leaders, policymakers, people who make funding decisions, and that kind of thing. So part of our role is to help people like that understand what they should be thinking about in this space. So machine learning is something we all hear about many advances in, so the question naturally arises, what's going on there that we want to know about, and maybe even more than that, what's going to happen that we want to know about? So here's what I want to do. So I want to take you through some of the things that people with cognitive disabilities would like to do. And of course, I'm selecting ones where there's maybe some prima facie case that machine learning might play some role there. And then you get into that. So what might machine learning do in some of these situations? What are some of the limitations, at least today, that might keep us from doing all the things we want to do? And then some maybe slightly miscellaneous points, but which I think tie in. So a lot of these systems are going to be providing assistance in one way or another, and some of those ways of providing assistance are kind of interesting in themselves. And so we want to talk about that. And then there are some risks, of course, to think about. And then I hope we'll have some time for discussion. So I'll start with this. So we all know that real soon now, this is what automobiles will look like. And the reason I'm mentioning this is you might not have expected this to come up in a talk about cognitive disabilities. But in fact, for people with disabilities generally, the likely imminent advent of autonomous transportation on a wide scale is a really, really big deal. So I worked as an advisor to a person named Charlie Clayton when he was director of the National Institute of Disability and Rehabilitation Research, a disability research funding agency. And Charlie would say that whenever people with disabilities are surveyed about the challenges they face in life, that quite commonly the top of that challenge list is transportation. And then the disability field, as represented by Charlie and many others, would sort of not really do anything about that because there wasn't much they could do. Outside, say, urban areas where certain kinds of supports can be offered. Well, autonomous vehicles are going to be great. So many people with cognitive disabilities can't drive, and this is hugely limiting for them. And another theme that won't be surprising, I think, to anybody, if you are a person with a cognitive disability, one of the things you're most concerned about is your independence and your autonomy. So you're used to being in a very dependent situation, and people in general hate that for very good reason. So this is a big deal. And of course, this is heavily dependent on advances in machine learning. So this is a great thing that's going to happen. So that's an example of something. Oh, there are lots. Not being able to read road signs in some cases would be an issue. Actually, you'll see more about this when we talk about some other cases. But having poor judgment, finding it slow, being slow to make decisions and choices. There's a whole range of things. So it's very common. I mean, not everybody, of course. And of course, well, I'm not really taking time to get into this, but the space, to call it that, of cognitive limitations or cognitive disabilities is extremely diverse. So there are plenty of people with cognitive impairments of one kind or another who can drive fine, but there are many people who can't.
Are you going to cover perceptual impairments?
No, the focus here is cognitive, but the lovely word comorbidity comes up, and that is important. So it happens that if you pick a person with a cognitive disability at random, it's quite likely that he or she will also have other issues, some of which could be perceptual. But mostly I'm going to be focusing on the cognitive side of things, in part because if I need any excuse for that, historically there's been way more attention in particular to supporting people with visual limitations, and then maybe next might be sort of deafness and hard of hearing, and then mobility comes in there somewhere, motor stuff, and until pretty recently, cognitive disability was hardly anywhere, especially when people were considering what might be done technically. So the focus here is cognitive. So here's a local example, and some of you may know about this. So this is a Stanford project, and this is an illustration of something that's happening now using machine learning to deliver some kind of benefit. So these are maybe Army surplus Google Glass things that are being used, as I understand it. And so you wear the Google Glass, and there's an app that drives it, and the app is capable of estimating the emotional state of the person that the glasses are looking at. And this is important for some kids with autism, for whom judging people's emotional state is an aspect of their general difficulty with social interaction. So what this thing will do is say, well, it looks like the person you're talking to right now is happy. Another interesting angle on this is that as it's easy to appreciate, classifying emotions from expressions is not very easy. And so it's worthwhile in this application to actually do special training on a per participant basis with people that they're likely to interact with, so family members or a teacher, for example. So in deployment, what they will try to do here is augment the sort of general background training that the system has in it about people generally, with making it particularly good at picking up the expressions of the people you're most likely to be talking with. I just learned today, literally, that there's an interesting and to me unexpected limitation of this, that this is great for some kids, but there are a lot of other kids for whom functionally this would be great, but it doesn't work at all. Anybody want to guess why not? Nope, they don't want to wear the headset. They won't wear it. So that's an interesting kind of crossover. Excuse me?
The kids that you're targeting this to are smart enough to understand the concept of emotions, they just don't pick them up.
Yeah, that's right. So this is, let's say, this is a pretty common part of autism, but another common part of autism is extreme aversion to certain kinds of being touched. And unfortunately, that interacts badly here. So and actually, we were discussing that this seems like it makes the problem a bit tougher, but there is the possibility of further developing the technology to deal with this issue. So a person who doesn't want to wear anything on his or her head might be willing to wear something if it was built into their clothing. And the reason this complicates the learning problem is that this is greatly aided by the fact that having it mounted in the glasses provides you like a really good front-on image of the face, and that would be tougher if you had to do it from, say, a chest-mounted camera. But nevertheless, so this is an example intended as, like with the autonomous vehicle thing, to say, well, there's already things happening that are going to do good here. So now we can move to other things that it would be great to be able to do that are not. It's not so clear what's going on. So Medicaid Waiver is a jargon term for a service that's offered as part of the federal Medicaid system. So every state has a sort of portfolio of these services called waivers, and the genius of our federal system is they're all kind of different. So there was a project which sadly is no longer in operation, which took all the descriptions of these waivers for all the 50 states and translated them into a more comprehensible form. And I'll give you an illustration in a moment. But here's kind of the raw form of it. So perhaps you can recognize this as, some sort of bureaucratese or whatever. And if you're thinking, well, this is a service that's aimed at people for whom cognitive processing is not a strength, maybe it's easy to see that having that translated into something like this form is really a good thing. So this was done by a human editorial process that included a self-advocate, a friend of mine actually, named Nancy Ward, who's a very skilled editor in this role. So the way this worked was that people who didn't have cognitive disabilities would kind of do their best to come up with what they thought was a more comprehensible description of this thing. And Nancy would more or less read this and say, so what is it that you're really trying to say here? And then the editors would say what that was. You'd say, well, why don't we just say that? And so the result is that. So I think you can recognize that statement is not only a lot shorter, but it's a lot easier to tell what it actually means. And I just said that this service is no longer being operated because it's expensive. It has to be maintained and all that kind of thing. So if we could automate this kind of process, this would be really great. And of course, this is just one of indefinitely many examples of this kind. So making text more comprehensible is something we'd really like to be able to do a better job on. We'll say more about all of these things in a bit. OK, so here's another different kind of example. And the background here is, this is an example I owe to a person named Paul Nishman, who works for an organization called Source America. So Source America is a federally chartered nonprofit that supports a federal job set-aside program. So our legislators, acting on our behalf, recognize that there are certain jobs that are pretty common in the aggregate across the whole federal system that are not very demanding cognitively. And so they've arranged that there's a hiring preference for these jobs for people who have serious cognitive limitations. And one category of such jobs is some groundskeeping jobs. So you can imagine somebody who's a groundskeeper at a VA hospital or an Army base or whatever. And Paul is who's an extremely capable and ingenious person and acts as a kind of national troubleshooter in this world. So somebody's placed in one of these jobs, and then Paul gets called in if contrary to expectation, the person actually had trouble doing whatever it is. And so he has a lot of interesting examples, and here's one of them. So one of his clients was on their riding mower, mowing the grass at some federal installation, and they came upon a patch of shrubbery, and in the shrubbery was a wasp's nest. So they stopped their mower and went and got the gasoline for their mower and poured the gasoline on the wasp nest and set it on fire, and in the process set the nearby building on fire. So fortunately, the fire was detected quickly, so it wasn't a true catastrophe. But this is an illustration, actually, if you think back to the question about driving. So here's a person where you could say, well, they just don't have good judgment. Okay, so they're looking at this and they're saying, wasp, this is a problem. I want to do something about it. Well, that's okay. It's perfectly reasonable. But then they're not able to make a good decision about what actions are reasonable and safe and prudent to take in response to that problem. So we'll be thinking about, what could we imagine that might be done to help in a situation like this? Could we imagine some form of artificial agent that could monitor what's going on in the situation, recognize this kind of thing? And again, we'll come back to this. So this is actually two tasks. These come from another friend of mine, whom I won't name. She's an attorney, actually employed in the federal government. She was employed in the federal government, but in her perfectly ordinary white-collar workplace, she suffered a freak fall and hit her head against some kind of a corner and sustained a very serious brain injury. This was several years ago. And, she, all things considered, she's doing remarkably well, but she would definitely say there are very many things that she used to be able to do that she simply can't do anymore, several years after sustaining this injury. And this is to say nothing about sleep interference and a whole host of other things. Well, so she learned, as maybe some of you know, that they're services from which one can hire remote human assistants. So the market that these agencies serve is, for instance, somebody who's, I don't know, a high-level freelance designer who travels around a lot from job to job and lacks a kind of a stable home base with an ordinary kind of resident administrative assistant. So the service allows such a person to contract with someone, in the case of my friend, it's in Mumbai, and this person in Mumbai assists you over the phone and by email and all that kind of thing. In the ordinary case, a common example would be making travel arrangements, say. But I'm illustrating here two of the things that my friend had her assistant do. So one was helping her manage her many prescriptions. So I've certainly had the experience, maybe you have as well, that I've got a prescription and I do what I think I needed to do, and then I go to the pharmacy and lo and behold, the prescription isn't ready for me, and so I have to cool my heels or come back later or whatever. Well, for my friend, that never happens, okay? Because her assistant working from Mumbai would place the necessary phone calls and let my friend know, okay, this prescription is actually ready for you to pick it up. You can go and do that. The gifts represent another thing. So my friend is a very generous person with a wide circle of friends to whom she often gives gifts. And she found that she couldn't keep track of who she had given what. And so one of the things she charged her remote assistant in Mumbai to do was to manage this state for her. So to avoid the embarrassment of giving somebody a coffee machine for this birthday or a coffee maker for this birthday when you'd already given them a coffee maker for their last birthday. Now, I've talked with her recently. She's actually no longer employing her remote personal assistant. The reason I'm stressing the remoteness is, as is probably obvious to you, the interface presented by a remote human assistant is pretty narrow. And so that kind of makes certain things about all this potentially quite easy for a robot or an artificial assistant. Anyway, in talking with my friend, she is emphatic. She would far rather have an artificial assistant doing these things than her remote assistant, even though she never had to see the remote assistant. And this relates to something I alluded to earlier. She hates any feeling of dependence on another person. This is just like salt in the wounds. It's bad enough not to be able to do something, but it's even worse if the people that are around you are somehow aware that you can't do them, even if, in this case, this is a hired person. Even so, she found that difficult and distasteful, and that's part of the reason she's not doing it anymore. I'm not completely clear, actually, why she stopped doing it, but that's an element of it. But anyway, as I was talking with her about this talk, actually, she was saying, boy, I would just love it if I could have an artificial agent that would do these things. So here's another of these situations. This one comes from a literature that's generated by parents whose children have cognitive impairments, and they write books about kind of what that was like and the challenges that they and their children face. So here's one. So there's a young man living at home, and one afternoon he's very excited because one of his friends is having a birthday party, and so the circle of friends are all going to the movies, a very much anticipated event. In due course, the son comes home from the movies, all angry, upset, really bent out of shape. And the mother, of course, is really distressed and says, well, Tom, you were so much looking forward to Julie's birthday. What happened? So he explains. So the story is that they all get to the movie theater, and Julie surprises all of them by saying, my treat, I'm buying the movie tickets. Great. They hadn't expected that, but terrific. As they're going into the movie, they pass the popcorn stand, and Tom says, so Julie, are you buying popcorn for us? And Julie says, no, I'm not going to do that. And Tom gets really angry and frustrated. He thinks Julie should have bought the popcorn. He's really angry about it. So the mother says, well, Tom, you had the money that you had with you to buy your ticket. You could have bought the popcorn. And Tom says, oh yeah, I could have. So two things about that. So first, in the event, Tom couldn't recruit that knowledge about the fact that he had the money and he could have bought the popcorn, and he could have resolved the issue that way. So that's, you could say, kind of his issue. But the further thing is, note that when the mother pointed that out, it was perfectly clear to him. So it's not like he somehow didn't understand the nature of money or any of those things. He's capable of understanding all of it. He couldn't recruit the necessary knowledge, as I think any of us would have. So again, we can ask, could Tom have had some sort of agent accompanying him that could have helpfully intervened in that situation and say, well, Tom, you seem to be getting pretty upset here, but I, having knowledge, and of course this is where the rub lies, and I'll try to do this, the challenge lies in trying to do this, the agent knows that Tom had the money and blah, 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 blah. Tall order, but anyway, we'll be talking more about this kind of thing. Okay, so what are we talking about here? So a few things we'd like to be able to do: make text more comprehensible, recognize when there's some kind of a deviation from typical or appropriate behavior, and then provide some sort of assistance in the context of ordinary day-to-day kind of transactions. So text simplification, a lot going on here, some of you may know. So this is just a kind of a splash of things. So IBM has an offshoot of their Watson technology, has something called the content clarifier, and you can see there are a bunch of things. Oh, I'm really interested. So Salesforce sees part of their bread buttered by the idea of being able to provide automatic summarization, which is an element of simplification, to help their clients. So they, I guess, feel that their clients often find that they've got too much to read, and so the notion for them of having stuff condensed is useful. So this is all progress, but I think one can argue that these things, sort of generic summarization, just kind of making things shorter, which is often done by just kind of selecting what content to retain, throwing away other stuff, and then simplification, which could include vocabulary reduction or restricting the syntax. That these things are progressive in this context, but they're only part of the solution. And the reason is, or part of the situation is, that some of what you want to do depends on what you think the reader knows. So you have to have some representation of that. And actually, in some cases, in order to make something intelligible, you have to add content, because whoever wrote the passage assumed the reader knew something or other, and the reader doesn't know that, and so you have to kind of add it. And I think we can illustrate some of this by looking back at that example I gave earlier. So I've kind of highlighted just some of the text there. So if we look at certainly part of the key of the translated presentation, it refers to help with day-to-day activities, which is, something which is a pretty meaningful sort of notion. And if you look at the original passage, there's really nothing that obviously says that anywhere. So I've highlighted a couple of things that you could say are sort of the basis of that. These references to functional this and functional that. But notice this isn't just a matter of replacing functional. So nobody would say out of context that functional meant day to day or whatever. So this translation makes sense on the basis that the entity that created it, people in this case, actually knew something about the situation being described. And they knew, well, okay, in this setting, what they mean by functional things has to do with support for things people have to do day to day. So this is so far beyond the reach of what people seem to be able to do with text simplification. Again, I'll say more about that again. So how about detecting unusual behavior? So this is actually work that's some years old now. So Tomas Izzo these days is over at Google. When he was at MIT, did what I'm showing here. So they created a surveillance camera arrangement where you could just kind of set it up anywhere and turn it on, and it would run and munge what it was seeing, and it would build a model of the visual dynamics that it saw happening out there. So in this example, they've had it watching a parking lot. And on the left, what you see is a graphical depiction of the dominant clusters of trajectories, which are differentiated by location, velocity, and also size. So the thing has absolutely no understanding of anything. So it doesn't know what a car is, and it doesn't know what a person is, but it does know that some things are big and some things are small, and it's able to separate the trajectories of big things and small things, which we know is the difference between cars and people. And then what's showing on the right there is that after some time of digesting all of this, it's able to flag episodes that fall outside the structure of these clusters. So it's not too easy to interpret those images, but one of them is a person who's found to be following a trajectory that people don't ordinarily take. In another case, there's a car that goes somewhere where cars don't ordinarily go, and it actually involves backing up, which cars don't ordinarily do in that situation. So this is progress, and actually, I haven't really developed this aspect of the topic, but there are situations which I think something very close to this, if not literally this, could be helpful. So to say a little something about that. So some people with cognitive disabilities get jobs that involve certain kinds of assembly operations or packing operations, so taking elements and putting them into containers for shipment. And a common fact there is that people can work very well at these kinds of jobs as long as everything's going kind of the way it's supposed to. But if there's some failure, which could be a defective part or failure of a supply of a part or anything that breaks up the routine, people need help. And what's sometimes done now is to instrument the workplace with a lot of special sensors to try to detect things like a part not being available. And as you'll appreciate, this is expensive to do and kind of brittle. You know, if you change something about the workflow, then you got to worry about redeploying, reconfiguring these sensors and whatnot. So it'd be very cool if instead you could have one or more of these surveillance cameras kind of watching what's going on. And what would you do if you detect something anomalous? Well, in these kind of settings, people have people called job coaches who are there to kind of backstop things. But to make that work, it's important that the duty cycle of the job coach be kept light so that he or she can be doing other productive work. You don't want them having to sort of be watching all the time what's going on. So this technology could actually be quite useful in that kind of situation. But in the gas can situation, I think we can see that we're looking for something that's a step up from that. So I stressed that the surveillance camera has no idea what the semantics of anything it's seeing is. In the wasp nest case, we'd like it, if we could, we'd like to be able to identify that some behavior is actually risky or dangerous. And an aspect of that would be that picking up the gasoline can isn't in itself something the person shouldn't do. I mean, they do need presumably to refuel the mower. So being able to recognize that the particular thing they're doing is risky, not so easy. And you might be thinking, and you'd be right, well, maybe you could hope to detect flame or something like that. And maybe you could say that under a wide range of conditions, flame isn't a good idea.
Well, are you going to get into the war hypothesis?
Huh?
Are you going to get into Benjamin Warp's work?
You can. I wasn't planning to.
Okay.
Yeah. Anyway, I'll just note that, and again, it can be useful to work on special cases like detecting flame, but at the same time, I think we'd all realize that if we do it in a more general way, that would be better. We'd have a more robust system. So we can think about whether that might be possible. Okay, so those everyday transactions involve working within a context that one has to understand. And then another thing is, so you might be thinking, so take the keeping track of gifts. Probably most people in this room could sort of script something that would do that. You could come up with some app within that interfaces with Google Sheets or something like that to keep track of it. But that's not really a starter here. Because doing that would fall in the category of things that my friend can't do. It's sort of complicated. So again, our aspiration would be to have a system that is more like her human assistant. So she didn't have to direct her human assistant by writing some kind of script. She could just describe in the way one would the activity of keeping track of gifts, and the person acquired the ability to do that. So we can ask ourselves, are we able to develop artificial assistants that have that? Oh, and then another thing, which any of you thinking about machine learning will be thinking about as well. I mean, something that shows up all the time is that we have a system that's able to do something, but first you have to give it 100,000 instances of the things like what you want it to deal with. And again, that's not going to happen in a lot of the situations we're dealing with here. Okay, so pulling some of these things together, and there's a big question mark then. Again, I'd love to know what you all think or what people you can put me in touch with think. But it was sort of a tentative assessment I would make is that these kinds of things I've just been stressing are really kind of at the frontier or beyond the frontier of what we're able to do. So take take natural language processing, where there's been a lot of progress. My impression is, I may be wrong, but my impression is that what people are able to do very well is to manage a limited amount of state in the course of traversing a document. So resolving backward pronoun references and stuff like that, this LSTM architecture, long short-term memory architecture, it can manage that kind of limited sort of within passage kind of state. But if you ask it to manage external state, such as who did you give a coffee maker to last year, it's a different deal. And another thing, as I just alluded to it, is there's a lot of stress here on, and it's a very active area of research, meta learning would be one aspect of this, trying to get it so that systems don't require a huge amount of training to adjust to a new task. And again, as I understand it, the high-level notion here is to identify some sort of family of tasks and do a whole lot of training on instances within that family, and then hope to find that that training generalizes so that very little training is needed to deal with a novel instance of the task. And there does seem to be progress in that line, but maybe not so close to what would be involved in some of the examples we're discussing here. So actually, another piece of work at Stanford that is, I think, responsive to this, I think is pretty interesting. This is who's a postdoc in CS here. And so I just want to give kind of a sketch of what they're up to. So they're developing a collaborative dialogue agent. So this agent plays a kind of a conversation game, which goes like this. So there's it, and then there's a human interlocutor. And both players are given a list of a short table with information about maybe a dozen individuals with different attributes specified. Same attributes for both players, but in different rounds of the game, maybe different attributes. So the attributes could include name, where somebody went to college notionally, this is all, of course, artificial, where they work, whether they like being outdoors or indoors, and I don't know how many attributes altogether. But the table, maybe as shown here, might have 3 of these things, and then descriptions, say, maybe of a dozen individuals with these different attributes. But then it's contrived that on any trial, there's exactly one individual in common between these 2 tables, and the tables are private. So if I'm playing the machine, I've got my table and I see what's there, but I don't see the table the machine has, and vice versa. And then the task is for these people to have a conversation which culminates in them knowing what the common individual is. And the report is they're able to play that pretty well. But what I think is interesting about it is the degree of robustness that they're able to secure here using a kind of a hybrid scheme. So the table that's provided afresh each trial is, you could say, sort of manually, by which I mean not using learning, but there's maybe I should just say procedurally transformed into a knowledge graph, which is kind of what's shown there. So that has, what are the entities and how are they related? But then, before any of this happens, there's been a training process in which the system has been exposed to that large number of examples of actually human-human dialogues. And what it's able to learn from that large corpus of examples is a scheme that allows it to take a new utterance and kind of decorate the knowledge graph with information about which entities are mentioned in the utterance that it's processing. And then it's also learned how to take a decorated graph and generate a representation of it, this graph embedding. And then there's an attentional scheme that processes that embedding and actually generates a response. And what I think is striking here is that what they've shown is that they can train the system so that it's able to function effectively if you give it a completely novel table. So maybe this is a success of that kind of meta-learning framework. So it's actually able to do a good job of generating a conversation about a collection of information that, it's at a very high level like the other collections it's had, but in every specific respect, it's different. So maybe this represents progress. Well, it does represent progress, I think. But we can also see, sort of back on this point about, what would be involved to really deploy something like this usefully. If we wanted to move it, and I've talked actually with her about this, so if we wanted to move this to a significantly different task, so for instance, we wanted to get it so that the conversation involved exchange of information, so somebody needs to be able to tell somebody some new fact and have them retain it. Well, then it's sort of back to square one. You'd have to kind of train that thing again. So, and that's not going to be workable in this sphere, this hoped-for sphere of human assistance. But nevertheless, again, I think this represents maybe some progress. Okay, so I mentioned this question of how assistance could be offered. And so imagine that we've sort of dealt with these issues technically, and now we're going to deliver. And there are a lot of things. So in the text simplification case, actually, there's work at Linz of developing a sort of an architecture that would allow somebody using a web browser to deploy a wide range of tools that, as we're able to develop them, that would allow them to have text rewritten in various ways. So that's one way that you could deliver some of this stuff. So another way, I don't know if people know about the IRA system. So this has been commercial for maybe a bit over a year. And it's today aimed at blind people. And the way it works is that if you're a subscriber, so it's a subscription service, if you're a subscriber, you have a pair of glasses with a headset and a camera and no display because you're blind. And this is connected to a sort of super cell phone. And you press a button on the phone and you're put in speech contact with a trained human agent, this person shown there on the right. And so I heard a talk by a student who's one of the early users of this who was saying, as a blind person, I want to tell you that there's something you probably have never thought about, you sighted people, but I can tell you it's a huge pain for me. I come to class, I need to find a place to sit. Okay, and it's really embarrassing because I kind of have to pat people down to find out that there's somebody sitting there. He says, it's great with IRA. I press the button and I say I need somewhere to sit, and they can see the room and they just tell me where there's an empty seat, and problem solved. So that's just one instance. I've been talking with my self-advocate friends and actually with IRA, and there's the prospect of creating a version of IRA that would support people with cognitive limitations. But the relevance of that to this talk is that the ambition of IRA, actually signaled by the AI in the name, is that whereas today this is all done by trained human agents, their estimate is they think the core of about 75% of their transactions could be automated. So what they're looking to do over time is to gradually reduce what human agents would have to do. So this is potentially an attractive way of delivering assistance. In the interest of time, I'm going to go quickly. I won't actually show you the in-own voice thing, but I'll just kind of tell you what's going on there. So there's at least one study in which they were offering certain kinds of prompts to a person who was a brain injury sufferer. And what they did was to record the prompts in the participant's own voice and deliver to them in that voice. And this may be responsive to what I said before. I mean, people really don't like sort of dealing with other people over things. And so perhaps delivering things in a person's own voice is a way to really kind of help with the psychology of that. But then I want to get to this direct brain connection. Actually, I'm going to do a little poll here. So how many people think, actually, before you get doing the poll, let me make this concrete. Okay, so I ride my bike to work every morning, and I do that by getting on my bike and riding to work. And I'm able to do that because I know how to get here. And actually, I know how to get here too, but so I had a meeting down in Menlo Park this morning where I don't know how to get there, and so I was being guided by my phone, okay? Well, what if, instead of my looking at my phone, which is the third party kind of a thing, what if my phone could be linked to my brain in such a way that if I need to go to this place in Menlo Park, I know how to get there, okay? In the same way that I know how to get to work, okay? All right, so this would involve being able to inject content in some way into my brain. So the question for you, the polling question is, how many think that something like this will be possible in 5 years? 10? 20? 50?
It's rudimentary now.
Huh?
It's very rudimentary now.
Yeah, that's right. But not the version I just suggested. Anybody think it's never going to happen? Oh, it's interesting. Okay, so we all agree this is something to be thinking about. So maybe you know this local startup, and I don't know these people, but I'm told they're respectable. So they're doing two things, both of which are really interesting. So one is they're developing non-invasive optics-based brain sensing. And in the upper part there, they're imagining or suggesting that they'll be able to track the movement of a single action potential. Pretty cool. But even cooler, you'll notice that they're projecting that they would be able to upload information to the brain, which is basically the scenario that I'm talking about there. So there's reason to think that this may occur, so it's reasonable to think about what it might mean. And you might think, well, that would be really creepy. I talked with my friend, she of the prescriptions and the gift list, and she said that would be great. I would love it if it worked that way. And actually, I've talked with Rob Rupert as a philosopher who worries about these things, and we came up with a view, very speculative, but suggests that there's reason to think that this wouldn't be creepy if it happened. So some of you may know the work of Jonathan Haidt, the moral psychologist, has actually done a lot of popular writing these days, and he relates his framework to that of David Hume in arguing that a good way to think about the sort of organization of the human mental machinery is that there's this little conscious rider up on top of this great big elephant, and that what happens is really whatever the elephant does. And the job of the rider is actually not so much to direct the elephant, although it has maybe limited ability to do that, but mostly it's to try to make sense out of what the elephant is doing and provide explanations and do diplomacy on the elephant's behalf and that kind of thing. But the claim is that the rider has very little insight into the internals of the elephant in any way. And so if you buy into that kind of framework, and there is, I'd say, a good deal of evidence for it, then maybe if we imagine that the rider somehow finds that it's no longer on top of just the elephant, but somehow the elephant has been supplemented by some kind of robot, well, the rider doesn't really know anything about the elephant anyway, so what difference is it going to make? So in the scenario of my biking to Menlo Park, well, I find that I can bike to Menlo Park, just as I found this morning or this afternoon that I could bike over here. It might not be so different. So it'll be interesting, and I think most of us feel this is going to happen on some time scale. And maybe it'll happen in a way that won't be actually very disruptive and won't infringe people's sense of autonomy and the like. I'll just note, so my colleague Brad Hayes, when he was at MIT and he's continuing to do this work, his interest is human-robot interaction, and it turns out there's an interesting parallel. So robot controllers are very complicated now. And so the kind of classical approaches to trying to figure out what they're doing, involving like analyzing their code and that kind of stuff, I mean, it just doesn't work very well. So what Brad and colleagues have developed is an approach where there's sort of a second robot whose job it is to watch the first one, and again try to interpret its behavior and make predictions about it and provide explanations and the like, which is essentially the architecture that Haidt is arguing all of us have. Turning to risks here. So this is a actually a really terrific post from Josh Lovejoy, who's in the Google People in AI research kind of grouping. And time doesn't permit getting very much into this. I'm hoping maybe some of you have heard at least of some instances of this. So maybe the best known example of a whole fleet of things that Josh is talking about here are these. People know about these sentencing guidance automata. So there was, I don't know if the business is still happening, I hope it's not, but there was a company that offered machine learning or sort of big data based sentencing guideline programs. And so if you were a judge, you could enter the attributes of the defendant into one of these things and get out a readout saying to what extent you should throw the book at them. Well, it turned out that based on the data that were there, if you were a black defendant, nothing to do with anything about you as an individual, you were going to get the book thrown at you. Why? Because that's what the data seemed to show. So Lovejoy is calling attention to that and many other examples of this kind of thing. Something that's related that some of you may know about, this is Virginia Eubanks of, I think, SUNY Buffalo, and her book, Automating Inequality. The sort of situation that Eubanks is pointing to is that well-intentioned people with the aim of improving the quality of and reducing the cost of social services are introducing various forms of automation. So basically replacing or maybe augmenting a small cast of caseworkers with algorithmic approaches. And what this leads to, kind of example Eubanks documents, is, for instance, a person who was required by guideline to maintain eligibility for certain benefits to come to an appointment with somebody and missed the appointment and had their benefit cut off. Well, they missed the appointment because they were in the hospital. And a human caseworker could kind of understand a situation like that and respond to it, but the algorithm this person was dealing with didn't. And you might say, what does this have to do with disability? Well, kind of two things. So one is, this is about the poor, as you see, but the overlap of the poor and people with disabilities is very substantial. The other thing is, some of you might know this, there's no such thing in US disability law or policy as a permanent disability. Okay, even though there, of course, are permanent disabilities. I have a friend who has a permanent disability. So every couple of years, he has to requalify for his benefits. Okay, so he has to again document that he can't walk. Okay, even though everybody would agree that his condition is such that he's never going to be able to walk, nevertheless, he has to do this. So people with disabilities do find themselves dealing with these kinds of bureaucratic agencies. So I think we need to ask whether or in what way people with cognitive disabilities may need to be concerned about the projection of machine learning, sort of data-driven, data analytics-driven kinds of technologies into their world in this way. So that's the end. So again, I return to my question. I'd love help from any of you in understanding these things. And I've put the sort of, just a small part of the sort of word salad up there. There are a lot of developments. So try to get an overview of what's happening. Some of you may know, well, boy, this great technology that's going to do exactly what you're interested in, and its acronym is the following. So I'd love to have that. There's my contact information, and I'll just mention one other thing. So the tiny URL there is, if people are by any chance interested in participating in a code sprint that's not exactly on this stuff, but it's related. So I'm visiting a social good nonprofit called Benetech, which works on inclusive learning. And so we're going to be doing a code sprint in Sunnyvale to get people together to do some brainstorming and prototyping of things that might be done. For example, to help struggling math learners would be one of the foci. So some of you might be interested in that or know people who are. Please get in touch. So that's all from me. So thanks very much for your attention, and let me take questions, comments, and suggestions. Thank you. Yeah.
So,
Oh, sorry, okay.
I think it's Parkinson's, that there's deep brain implants or some buzzword like that they're putting probes way down in there and feeding stuff in that makes people work better. So the idea of tapping into neurons is
Yeah, I mean, that's right. I mean, I don't know where you were in your, actually, what was your vote? When do you think we'll see brain upload? How far out? You going to be dead? It's going to be in your lifetime?
You haven't defined brain upload yet.
Well, so knowing how to get to Menlo Park or the Starbucks at 1401 Willow, Menlo Park, knowing how to get there. You're shaking your head. Yeah, okay. But let me note, actually, I'm curious, anybody here done any direct current brain stimulation, transcranial brain stimulation? Okay, so, well, okay. Huh?
Tens units. Tens units.
So you have done some?
I've got that peripheral to the brain. But
How was it?
well, if you stimulate
No,
muscles.
through your head. Have you done that one? Has anybody done the one through your head? So with a 9-volt battery and a 50-cent current regulator, you can do this. I haven't done it.
Samurai guys do that.
Okay, so there's a guy named Frank Palermo, who's a really interesting guy. He happens to be based in Boulder, and I think he became very wealthy developing a really powerful rehab technique involving electrical muscle stimulation. So he came to talk to me about something, and he asked me about this, which I knew nothing about, which I still know hardly anything about. So he described it. So you put electrodes on your head, and you put a little bit of current into some part of your brain,
You don't
and
want to electrolyze your brain.
well, okay. So yeah, let me. That's where the current regulator comes in, I guess. Okay, but anyway, so Frank is describing this, and I'm describing the various risks that it seem obvious are involved, and I'm also thinking, well, can this be legal or whatever? And Frank said, well, NIH has been really interested in this, but the more they've studied the potential risks of doing this, the more they've found actually that there aren't any risks, but there are benefits. So Frank himself said that doing this, he became much smarter. So the way he described the phenomenon is the way, so I don't know if anybody's been on Ritalin or taken somebody else's Ritalin. People do that. And when they do, they sort of describe, gee, I can focus much better and all that kind of thing. And that's how Frank described this. So I asked the obvious question. So I said, have you continued doing it? And he said, no. And I said, why not? And he said, I didn't like the person I became. But nevertheless, there's apparently something real there. Were you going to comment on this?
Indirectly,
Okay.
we have I've had a friend all my life who was born, we called it retarded back then.
Yeah.
But he's a savant. So he's in our social community, he's memorized everybody's birthday, everybody's wedding day, college graduation, and he memorized everybody's divorce dates. But his mother told me I had to forget that. The problem is he remembers like too much.
Yeah.
My father was a builder, and he gave him 2 catalogs of doors. And within like about 2 weeks, he had memorized both catalogs. He knew every kind of door in existence. The problem is, he probably could read a DMV booklet and a car manual in about an equal amount of time and have them totally memorized, but he still couldn't drive.
Yeah.
So there's a little thing, your thing about like the problem with putting something into your brain it might get into the wrong part, and all you would be able to remember was how to get to that one place, and now you want to go somewhere else. And all your brain would bring up would be this other thing.
Yeah, indeed, a lot to.
Also, how do I do it?
Yes.
You can't just simply erase.
Yeah, you need a forgetting
Oh,
process.
yeah,
That's why the fMRI guys have strict limitations on that, because it's not as predictable.
Yeah, lots of things to worry about.
It's not important now.
Yeah, but actually, what you're saying about your friend reminds me of something else. It was illustrated in the conversation this morning, and people may know about this. So there's a lot of reform being attempted in the education space, which broadly takes the form of recognizing extreme human diversity and working with it instead of, as is so often the case in the educational system, trying to sort of discipline everybody. And some of the results of doing that are really extraordinary. So if you put people in a situation where they're able to do the things that they're able to do, as opposed to spending all their time trying to do things they can't, sometimes the results are remarkable. So I was hearing from actually a person named Marina Wasserman, who actually does some work with the Ed School here, and has a school in Menlo Park. So she was telling me that the first 2 non-speaking students have now been admitted to the UC system. So these are people who communicate using what's called a symbol board, where they're pointing to characters on a board and working with a sort of transcriptionist who can do that. And if you ask the obvious question, why aren't they using a keyboard or a touch screen? The answer to that is not very clear, but the answer is that they can't do that. Why they can't do it is unclear, but what they can do is use like a paper board. And the suggestion is it has something to do with the details of the motor interaction. So Marina was speculating that there's something about being able to position something in a precise way in your sort of body coordinate system, and sort of rigid things like tablets and stuff like that just don't allow people to do that. Sorry, who?
That's what Stephen Hawking was doing
before
he got the support from computer people.
Yeah, that's right. So Hawking was doing it because there wasn't an alternative, and then he switched to the tech. But these are people for whom all the ordinary alternatives, which work great for a lot of people, just don't work. So again, the message is people's abilities are extraordinarily quirky, but if you're able to work with them, the results can sometimes be remarkable. Other thoughts?
There's another category you might think about. Some people, their brain is just wired so they can't do face recognition.
Yeah, prosopagnosia, yeah.
The little glass setup, might be able to actually solve that one.
Yeah. So I can't resist. That triggers something else, and maybe people know about this. And I'd have to dredge up the reference. So if you're interested, if you send me an email, I'll do it, because I'm not going to be able to dredge it up from my brain. But there's good reason to think among vision scientists that we have on the order of 6 visual systems. They share the same light sensing apparatus, but beyond that, they're actually dissociatable. So there was a dramatic case of someone who suffered carbon monoxide poisoning, which sort of randomly knocks out some portion of the brain. And after this experience, the person believed herself to be blind and was believed by everybody to be blind. And right there, you might think, well, this is crazy. How could someone, you're either blind or you're not. How could you believe yourself to be blind? Okay, so this person who believed herself to be blind and was believed by others to be blind, happily started working with a psychology research group. And one of the things that happened was that the group went out for a picnic in the nearby forest. And then somebody noticed that this blind person was able to follow the group along this rutted trail with roots and rocks and everything flawlessly. So to kind of cut to the chase, the visual system, the portion or the aspect of the visual system that guided motor movement for this person was intact. But the portion of the system that gives rise to our familiar phenomenal sense of seeing things was not working. So the person had no conscious awareness of what was going on. And they developed a procedure to kind of probe this, which went like this. So they set up a table with a slot mounted on a sort of a gimbal so that it could be turned. So the slot could be given any orientation. And the person sitting on the other side of the table and is given a card, and they're asked, what's the orientation of the slot? And they'd say, I have no idea. I can't see the slot. Put the card in the slot. Okay, and they did video recording to establish that they had oriented it correctly well before it reached the vicinity of the slot. And then eventually, she acquired the ability to actually say what the orientation was. And the way she did that was, she would pretend she had a card in her hand and that she was going to be putting it into the slot, and then she would observe the orientation of her hand. So that's actually, I hadn't thought of this before, but that's kind of an example of this elephant idea. Okay, so the elephant knew how to orient the card. The rider could acquire knowledge of the orientation from noticing what the elephant was doing, but the writer had no phenomenal visual experience at all.
Right brain, left brain, after they cut it or
Yeah,
something.
yeah,
you
separated,
You ask
yeah,
one side of the
yeah.
brain and the answer is, I
Yeah.
don't know, but if you ask a variation of the problem, it does the right thing.
Yeah.
Blind people can do that too. With a simple scanner, they can reconstruct. We had a student who learned to read complicated circuit diagrams just from scanning the whole thing.
Uh-huh.
And he could see it any order.
Cool.
Eventually, we couldn't tell the difference.
So I'm curious.
We even blamed him. He didn't turn the light off. And then said, "Oh no, you can't see." Yes, he could. He said actually he'd hear if the light is on, the hum.
Huh.
They automatically translate basically.
I'm curious to hear from the students. Any of you going to work on any of this stuff? Like brain implants? Or, I mean, it's happening here. You could do it. What are you going to do instead?
It seems very interesting. I think it would be very interesting working with neural prosthesis and stuff. So,
Yeah.
Yeah, I guess that's good.
Okay. All right. Great.
Yeah.
Yeah.
Thursdays at noon in the Clark Center is the neurosciences lunch talk. And it would be really interesting and they serve coffee and cookies afterwards, so there's an opportunity for conversation, both before and after.
Uh-huh.
And you could get some of these questions answered in the
That'd be great. So if I Google that, will I find it easy to find out, or?
neuroscience.stanford.edu
Okay.
Events.
Cool. Great.
I was going to say that I'm kind of a bioelectrical engineer, and people have asked me to build these brain implants and stimulate.
Yeah.
And I've built them for people and things like that. But what's bugged me the most is people that use them don't have a clue what they're doing. They don't have a clue what's going to be the result of what they're doing at all. And one study that I thought I'd just tell you about briefly is 45 years ago in Ann Arbor, Michigan, some of the neuroscientists, they put air bubbles underneath between the dura and the pia in the brain and just put a pressure pulse.
Uh-huh.
And they did it to about 334 patients. And about 10% of them had a weird effect afterwards. That took about a week to develop for them to determine what was happening.
Yeah.
And about 2 weeks later, that bubble had resorbed.
Yeah. Yeah.
And they lost the ability. But about 10% of those 334 patients became some kind of savant.
Really?
And different types of savants.
Unintended consequences.
Totally unintended. Once again, these people don't have a clue what they were doing.
Right.
But
Subconscious.
they were putting pressure on the brain.
Interesting.
And I thought that was interesting.
Even if blind people, a lot of that is on
So
subconscious.
if I Google air bubbles on the brain, will I find out about that?
This is prior to the internet.
Well,
45 years ago.
still, come on. If somebody wrote it up, it's probably out there somewhere.
Lots of stuff happened before the internet.
Yeah.
Yeah,
David.
it strikes me that that there may be other people interested in enhancing cognitive abilities, particularly in the military,
Uh-huh.
that may be doing similar kinds of research to yours, but may have less altruistic goals. I'm interested in your exposure to that.
Boy, that's interesting. So I don't really have any. I mean, of course, that means nothing about whether it's actually going on. I will say that. So I mentioned briefly working as an advisor to Charlie Lakin at the National Institute for Disability and Rehabilitation Research, and we were seeking federal partners. This NIDR never has enough money, and so we had some interesting discussions with IARPA, the Intelligence Advanced Research Projects Agency, and they were actually quite keen on working with us because they at the time, probably all the time, they could use good press. And there were a number of technology they were working on, not so much pertinent to this, but they do a lot of stuff in language and speech processing that could be quite useful. But so far we haven't quite secured crossover. But you're right. I mean, there are lots of reasons people are interested in this kind of thing other than this. But yeah, actually I should try to find something out about that.
ways to make the brain just work better? No, I'm
Oh,
serious.
wouldn't that be nice?
No, Fred here had normal pressure hydrocephalus, and the space in his brain that held the liquid was pressing
The
against
ventricles.
ventricles,
Right.
pressing against
Yeah.
certain parts of the brain. So they, like, one of them was short-term memory, so it wasn't working very well. And that was one of the symptoms that had me going like, aha, there's something going on here.
Yeah.
So we had him checked out, and they put a shunt in to drain the ventricle.
Yeah. Yeah.
But the,
Interesting.
But I just got thinking, maybe there's ways of
Well,
catching that early.
that's
if you
why I mentioned this direct transcranial direct current brain stimulation, and I fear that I was sort of too flip in describing it, and I'm going to continue that a little bit. If you go on YouTube, you can find some pretty funny stuff of the form. You know, some young person, forgive me, is very excited. You know, as I took such and such standardized test and I stimulated myself here and my score went up 10 points, but you know, then I got this kind of buzz. You know, so I moved them over here and I took it again and I got 15 points. But so again, I'm undermining my own case. But apparently there is the serious finding that this kind of stuff does things, and maybe it's, you know, in a way, to me, it's similar to the thing about the air bubbles. As far as I can tell, there's no rational reason any of this should do anything in particular, and maybe it doesn't. Maybe its effects are pretty random, but it does seem clear that it does things.
The short-term memory could be given more space, then relevant, you know, everything would come in and relevant things would get weeded out before it got into long-term storage.
Yeah.
You can find people on YouTube who
world
take
out there.
electric drills and drill holes into their head.
Well, that's, of course, that goes back to BC.
Things you like to avoid, yes.
Yeah.
Yeah.
Well,
Yeah.
just north of you, of course, is Temple Grandin at Fort Collins. Do you ever interact with her?
Yeah, a little bit. So the Coleman Institute has conferences, and Temple's been a speaker in that setting. And actually, I'll mention there that you know, autism is actually it's very big around here, demographically and sort of politically and otherwise, and very contentious area. But one where the self-advocates are, many of them, you know, extremely outspoken. That this idea of really accommodating people and not trying to push people to be some way because you think that's how they ought to be, but instead to go with how they want to be is really important. You know, Temple, as far as I know, kind of escaped a lot of that. But there's some pretty horrendous stuff you can read out there from adult people with autism about how they were treated as children. But again, the theme, I think, the progressive theme here is really working with people and their differences. Yeah.
You mentioned, this is a little bit off topic, you mentioned earlier that there may be several types of visual systems and we're only consciously aware of all of them. The person who could. Can you quickly say what those other types might be, or where this has been documented, where I can learn more?
Well, if you drop me an email, for some reason, this is the first author is just one of those names that doesn't stay in my head, because that's a longer list every year. But if you send me an email, I know I can find it. But briefly, I'm not going to be able to count up to 6. But there's the phenomenal awareness one. There's the motor control one, the one that guides your feet. And then, as was mentioned, there's face, but actually I don't know the latest science there. So I guess it's not literally faces, but maybe that's the main use of it. But anyway, there's some sort of special geometry engine. And to say a little bit more about that, you know, when we look at the world here, you know, we have the illusion of living in a kind of homogeneous geometric space, you know. So there's the geometry of this chair, there's the geometry of your face, and they don't look different. It's not like your face lights up somehow. But there's a lot of evidence that my perception of your face is completely different from the perception of the chair. It's somehow all woven into this deceptively uniform space. So there are 3 of them, but apparently there are a few others, and I don't know what they are.
Well, did you attend Michael Gazzanico is just here?
Oh, really? Okay.
I haven't seen his new book right now, but
Yeah, I haven't heard him speak for a long time or followed what he's been
I
doing.
didn't buy
But
his textbook for class.
aha, okay, yeah.
The description I've seen of face processing is that they've got good MRI data, that there's a region that does it. And one description was as soon as the guy figures out that it's a face, it disappears. If he's looking at something,
It's
a hard to
extracted.
recognize picture, and it ends up being a face sideways, and then he figures out that that's an eyes, and it isn't a face yet, and then he sees the nose, and it just goes poof. My model was there's a switch. It says,
Yeah.
everything else and faces.
Vera, I think this sort of fits in with the hey, elephant idea that, there's every reason to think there's lots of complicated stuff like that going on, and we're utterly unaware of it. It plays no role in how we experience the world, or no direct role in how we experience the world.
Well, we're about to lose the thing.
All right. Well, thanks, everybody.